I use a tool called the test coverage matrix to help me measure the effectiveness of my entire test engineering process. So many people just focus on flying probe test or just AOI or just functional test. Whereas, isn't it obvious that if I can catch every possible fault somewhere in my process, then I've got a pretty good process and I have a good chance of achieving that 300 parts per million escapes. That's a pretty good process if you can do it. How can I do it? Well, you do it by documenting your test coverage. So I have what I call a test coverage matrix in order to achieve that. So there's lots of tools in the industry for being able to do this. The in-circuit testers and the flying probe testers have automated tools that will generate most of these reports. So let's take a look at some of these reports so you can understand what they are. So I have this as 3 different sections. Instead of going through this in the overview, let's just jump into the report itself. I have a sample report for you. You'll see this report on your CD if you're downloading this video and all the documentation, there'll be a TCM spreadsheet, test coverage matrix spreadsheet. Take a look at that and you'll see these slides. This is a real board that I did for a real customer, but I went in and I changed a whole bunch of part numbers and I changed a whole bunch of things, and you don't get a net list, so there's nothing inappropriate, or I'm not violating any kind of non-disclosure agreement here. But this is a real board that I did. The board was not designed for testability, and so implementing ICT was not ideal. There were lots of devices I could not test because the board did not have design for testability. With my test points, I had resistors and other circuits that caused some caps to be untestable. Shame on them for not designing the board correctly and implementing what we talked about in section 6 regarding design for testability. So if I just look at my overview first, I've got a whole bunch of devices here, or device pins, that I cannot detect anywhere in the process. AOI isn't catching it, ICT's not catching it, functional test, unit test, burn-in, there's nothing in my whole process that's catching this. Now in this example, I'm giving you an example of ICT, functional test, and burn-in. It could just as easily be AOI, functional test, and HALT, or it could be AOI, ICT, and a final test. Your mileage may vary depending on what you're going to do for this particular board in the process, but I'm just showing those 3 levels of test. So for example, sometimes it's hard, in some cases impossible, to catch a cap when it's in backwards. Ceramic polarized capacitors in the industry today are notoriously difficult to test for orientation. So in this case, I'm documenting that that's untestable. If you have some kind of camera like AOI or flying probe, I can use the cameras to verify orientation. But ICT and functional test, there's no electrical way of doing it unless you have lots and lots of time on your hands. So there's not a practical way of testing a cap for reversal when it's a ceramic polarized cap. So if I look at some of the other devices that are untestable, for example, a Zener, it might be testable for forward drop, but I can't test the Zener value. So theoretically, they could put a signal diode where that Zener goes and it'd still pass the test. So that's the sort of fault I need to test for and somewhere in the process, but the process as it naturally occurred is missing all of these faults. Here's some statistics down at the bottom. You can read those at your convenience. The heart of this is my slides to show you what's testable and not. What I like to do is list every device in alphabetical order, put some kind of value to all the part numbers with the ICs and transformers and such, so that every device is listed. On some devices, they have 2, maybe 3 different fault classes I might want to look for. The example on this page is C10. It has a value of 33 microfarads, but it's also polarized, so I also need to be able to make sure that it's not inserted backwards. So how do I do that? Well, the way I document that is I show you C10, I can test it for value, but I cannot test it for orientation for whatever reason. And C19, I've got a couple of resistors in parallel that's not guardable, and so it's not possible to test that particular capacitor. And what I'm showing is functional ICT can't catch it, functional test can't catch it, unit test can't catch it, neither can burn-in. So my whole process has that device untested. What do I do? Well, I think I need to add something. I need to add a person doing visual inspection if nothing else, right? I could add AOI or some other kind of step just to make sure that that kind of fault is caught in my process.